और भाई आज तो बहुत इजी क्वेश्चन है। सो लेट्स जल्दी से खत्म करते हैं भाई इसको। तो आज गिवन क्या है, वी हैव गिवन इंटीजर एन, राइट? ओके, एंड वी हैव टू टेल द जीसीडी बेसिकली ऑफ odd and even sums. Okay, so what is GCD of two numbers a comma b? Right, this is greatest common divisor. Okay, what is sum of odd numbers? Sum of first n odd numbers, n square. भाई मतलब नहीं पता तो ड्राइव कर लेना भाई, बेसिक अर्थमेटिक प्रॉब्लम है। और फर्स्ट एन इवन नंबर्स, एन इंटू एन प्लस वन। अगर ड्राइव करना है तो ऐसे करना, राइट? 1 + 3 + 5 + m, राइट? तो फिर अपना अर्थमेटिक प्रोग्रेशन का सम क्या होता था उससे कर लेना, उससे हो जाएगा। ओके, so now we have to tell the GCD of these two numbers, right? So our a equals to what? N cross n. B equals to what? N into n plus 1. Now see, डायरेक्ट लाइब्रेरी फंक्शन यूज करो, एक लाइन में हो जाएगा। यू जस्ट से जीसीडी ऑफ ए कोमा बी, राइट? हो गया, वन लाइनर खत्म। Just tell me, I am an interviewer, you come and you tell me just use GCD function. Will he accept it? No, never. So that's why we are going to use the Euclidean algorithm here. यार स्पेलिंग देख लेना, Euclidean algorithm. Okay. So what does the Euclidean algorithm say and what it is? First, let me tell one important property of GCD. See, right? If A and B are two numbers, right? Both has a common divisor, C. C. Then can I say that GCD of A comma B minus A will be same, right? That GCD of A comma B equals to GCD of this thing. Why? Because if A has a common, right, I can write A as some C multiply X, right? Then I can write B minus A equals to, right, C into some Y value. I take C common from both of these, right? I can definitely write this, right? Then I can say both C, C are common there. Okay, so GCD of A comma B can be written as GCD of y A comma B minus A. Similarly, if this is some number x, then again can I write a GCD of something, right? Again the x comma, again I replace, right, x minus A. Can I again go ahead and call it same? So it's basically a recursion. Now see, if if I have two numbers, right? Let me tell you 7 and 35, right? Then what first you are going to do, right? 7, what is 7 for the 20, and what you will do, 7 keys and so on, right? So it's basically linear, right? What other thing I can do? Can I write this like 7 comma 35 modulo 7? I will just remove the entire, right? Just entire number, right? Just take mode. If there is a divisor, you take mode. So all, right, all multiplications of that number you remove, right? So if we can write, right, 35 as 7 into some blah blah blah. So we just remove the 7 at all. Then it will be left as, right, 35 modulo 7, which is equals to 0. So if we remove 7, there is nothing. So can I write the above equation as, right, GCD of A comma B equals to GCD of B A modulus B. Can I say this thing? Right, I can say this thing. And also just tell me one thing here. If it's 0, right, then GCD is what? 7. See, if one number is 0 and you want the other thing, right, then it's definitely 7, right? Okay. So the base, right? So we'll just write a recursion, right? GCD of A comma B, right? If B equals to 0, what do we do, right? Return A, right? Otherwise what? Return GCD of B comma A modulus B. Just simple. And what will the time complexity of this one? This one is of log of maximum of A comma B. Yep. Let's see the code part. One liner. So let's see what do you have today. Bicep day today. Okay, so in the question, right, we already see the approach. What we are going to do, we need to first write the euclidean algorithm, right? So I'll just say GD and A and B, right? Right, what is the base case? If B equals to 0, we return A, right? Otherwise, what do we return? We do return of, right, GCD B, comma, A modulus B, right? And right, what is sum of first n odd numbers, right? It is n cross n. Sum of first n even equals to what? N into n plus 1, right? So I'm going to return GCD of what, right? N cross n comma n cross n plus 1. So see, we can always write the library function here, right? But never do that file, because if someone asks you this question in the interview, right, they will not be happy. So also I am not happy. GCD of odd even sums n cross n. Okay, okay. And don't do these silly mistakes. I hope this will work. For some reason, my internet is very slow. Sometimes it happens. Okay, so it's accepted. Yeah, thank you. Okay, so this is Euclidean. So okay, just remember this thing, right? So it's used a lot of time, and there are some properties of GCD which I already told you while explaining this, right? So just make sure to remember that.